Greetings to you and welcome specially to Bengineer Construction Lecture Hub. Ah, and I hope your day was wonderful. You're welcome. I welcome you specially to this live streaming. Yeah, so if you're joining us, today's topic is centered on the effect of groundwater to foundation stability. So, you're welcome. Yeah, you're welcome. So, without wasting much of the time, I want to, start the, the lecture for today. All right. So, like I said, today's lecture is centered on the effect of groundwater to foundation stability. Now, as you know, foundation is a substructural part of our building, and it is found below ground level. Now, most times you see that foundation plays a very integral role in the stability of the structure as well as its longevity. Okay, because when your foundation is faulty, it means that it will hamper the totality well-being of that structure. All right, so that is why it's important that we pay critical attention at that substructural stage of work. All right, so we want to look at the effect of groundwater to foundation stability. Now, you know that when a building, or rather when a foundation is stable, the entire structure is stable, at the same time. All right, when the foundation is weak and faulty, definitely the entire structure will also have that negative impact. All right, so today we are going to look at the effect of groundwater to foundation stability. Now, our foundation rests on the soil. All right, and we have different types of soil. Okay, we have different types of soil, and all of these types of soils behaves differently when they are loaded. All right, you have the clay soil, the sandy soil, they all behave differently when they are being subjected to gravity load. Okay, so that is why it's important that we study the soil. Okay, the soil, the soil we intend to put up the structure. We study it to understand both the behavioral and the properties of that soil. All right, because most times you see that water tends to influence the behavior of these soils, okay, with respect to foundation, because foundation rests on the soil. Okay, so and that is what we want to look at today. Now, you see that when our soil is being loaded, as in is being loaded, you see that foundation becomes the receiving end of the transfer system. Now, it is from the foundation that the load leaves to the soil. Okay, so it is the foundation that has an interface with the soil. Okay, so the way the foundation behaves, okay, is very, very important, with respect to the stability of that structure. All right, because most times you see that our buildings undergo failure, structural failure. Okay, you discover the uneven settlement. All right, all of this emanates from the foundation. There are situations we have tilting. Okay, you see the building tilting towards a particular direction. This is as a result of problems in our foundation. All right, so we want to look at the effect of groundwater, because groundwater influences the soil around every structure. All right, groundwater influences every soil around all structures. So it's important that we have to understand how this water influences these types of soil with respect to foundation stability. Okay, now I want you to understand that in clay soil, for instance, clay soil is known to be dynamic. Okay, it changes. All right, there is this, or it alternates. All right, as a result of the seasonal cycle. Clay soil swells when it is wet, all right, and shrinks when it is dry. All right, so in a location where you have your structure and that area is predominantly clay soil, have it in mind that that structure will experience these characteristics of clay soil. All right, and usually it is the groundwater that influences the swelling tendency of our clay soil. All right, because once there is a rise in water table, that is the piezometric level of groundwater, once it rises, you will see that it gets close to your foundation. Probably the depth of your foundation might be close to the piezometric level. It means that at that point, the water will tend to, get saturated, around the foundation soil. All right. And when that happens, you see that the weight of your structure will respond due to the swelling nature of that clay soil. All right. So once it happens, it means that there will be a drop. Okay, there will be a downward movement of that structure as a result of that swelling nature of the clay soil. Okay, you're welcome. If you're just joining us, you're welcome to Virginia Construction Lecture Hub. This live streaming, we are talking about the effect of groundwater to foundation stability. All right, so if there are questions as regards to the topic of discourse, you can drop them at the comment section. All right, then if there are contributions as well, you can also drop at the comment section. So like as I was saying, for the clay soil, you see that water tends to influence the behavioral pattern of clay soil under load, and it is the foundation that rests on that soil. So you see that when the groundwater rises, the clay soil around that foundation area tend to absorb this water. Now when the clay soil absorbs this water, you will see that the clay soil will swell. All right, all of this happens substructurally. You won't see it because after your foundation work, you see that backfilling and infill have been, will be done. So you wouldn't see what goes on below the ground level. All right, but we have to understand how this transfer of load behaves, okay, with respect to foundation stability. But we are looking at groundwater. So like I said, the groundwater here now have a direct impact on the foundation. The reason is that, for example, if you're looking at clay soil, you see that clay soil swells. It takes water once there is rise in groundwater. Okay, clay soil rise. Now, once it rise, the soil around the foundation, especially the footings, the pad footings, okay, tend to take this water, and once they absorb this water, they swell. Okay, and when they swell, you see that the weight or the gravity force, or the load from the structure tend to exert on that swollen clay soil. So you see that the footing will tend to displace that area that is swollen. So that is what results to the downward movement, okay, of our substructure. All right. Now this downward movement usually have a direct impact on the stability of our structure. So that is why you see in some cases you see structures tilting towards a particular direction. In some cases, you see uneven settlement, that is differential settlement. You see some part of the structure leaving the other part of the structure, and this usually takes place substructurally. All right, and it is usually influenced by groundwater. So most cases, you see that the foundation fails. Okay, they fails when this soil undergoes this behavior, especially the clay soil. So that is why it's important for us to consider the introduction of, kind of rafting our foundation in clay soil. All right, so that in the case of uneven settlement, it will help to regulate those tendencies in our clay soil. All right, and once it regulates that tendency, it will give stability to our foundation. So it is very, very important. Then in the case of sandy soil, all right, in the case of sandy soil, you see that sandy soil, once there is water, in an area where it's predominantly sandy, you see that there is tendency of liquefaction. All right, you see that sand, not having, because of its cohesionless nature, it doesn't have that stability. So it is the water that influences, it makes it flowable. All right, and when that happens, you see that most times our foundations are exposed. All right, our foundations are exposed. You see in some cases the building tend to tilt towards a particular direction, that is towards the direction where there is the weight is being directed to. All right, this is from the foundation. So automatically the foundation is responding to the tendency, that liquefaction, within the sandy soil. The foundation will respond towards that behavior of our sandy soil. And when that happens, you see our structures tilting towards a particular direction. All right, so it's important that we understand this behavior of our soil, because our foundation rests on them, and it is groundwater that influences their behavior. All right, then there are some cases we have peat soil, we have made-up soil. All right, made-up soils are mainly areas that have been a kind of abandoned, a kind of dump site and all of that. You see that the soil there will not have sufficient capacity to carry load. All right, so when you build in that kind of structure without considering groundwater there, okay, to provide suitable foundation for that kind of soil, you see that it will have a direct impact on the stability of that foundation, and that will automatically, transcend to the superstructure, because whatever that happens in the substructure that is unseen are usually manifested on the superstructure that is visible. So that is why you see in some cases we have cracks, all right, on our superstructure. Now, when you trace those cracks, you see that most of those cracks are associated to differential settlement. They emanated from the foundation, all right? And in some cases, if you don't adopt a suitable foundation, especially in clay soil, which is predominantly in the location where I am, all right, is more of clay soil, all right, and the water table is always high. Okay, so that is why in this location, when you're doing your well, your borehole well, you don't go you don't go deep that much. Okay, you don't go deep that much because of the water table. But most times it is important to get to the aquifer. All right, and that is why in most cases when they are doing borehole drilling in this location, once they go to maybe let's say 20 feet, all right, the water will start, they will start accessing water. But most cases, those are aquiclude, all right? They get water when the water table is high. But once the water table, the piezometric level drops, okay, you see that that well will no longer be able to, supply water. There will be no availability of water, to extract. So that is why it's important we go further and assess the aquifer. Okay, when you get to the aquifer, you see that there is no seasonal changes, doesn't affect the recharging of water in that layer or that zone. All right, so in this location is mainly clay soil, all right, that is found around this area. So that is why it's important you must consider this dynamic nature due to the compressibility and also the expansive nature of clay soil. All right, water have a great influence on clay soil because of that swelling tendency. And most times you see that structures or construction works are carried out in the dry season. All right, in that dry season, when you see the clay soil, you see it in its hard state, especially the stiff clay. You see it in its hard state. Now, in that state, it is very hard. Okay, you can't even compress it because of that dry nature. Okay, so that is why at that period in time, the bearing capacity is high. Okay, but once it is wet, the bearing capacity is low. Okay, so you must understand this behavioral pattern of the clay soil, and that have a great impact on the stability of our foundation. So most times you see that we carry out construction work during the dry season. Okay, now when you, at that point, when you load the soil, all right, during the cycle, that is during the wet season, you see that the groundwater will rise. Okay, and once the groundwater rise, the groundwater will, the soil, the clay soil, tends to absorb this groundwater. In fact, the entire soil will be saturated. Okay, and when that happens, you see that the soil will swell. Okay, the clay soil will swell due to the presence of minerals. Okay, due to the presence of minerals that causes those swelling tendency. All right, so because once those minerals takes water, they tend to cause the swelling of our clay soil. Now when it swells, all right, remember the structure was built during the dry season. All right, during the rainy season now, you see that once that soil around the foundation, the pad base, gets the water, it swells. And when that swelling takes place, you see that there will be a downward movement, although it is not noticeable. Okay, it's not noticeable, but that is settlement. All right, so it is groundwater that influences the settlement of our foundation. It could be uniform settlement, it could be differential settlement. Now, this uniform or differential settlement also depends on the kind of foundation given to that structure. All right, because if your structure is monolithically connected, that is substructurally, you will discover that there will be uniform settlement. Now, the uniform settlement I mean in this case is that the entire substructure, the entire structure will go down, uniformly. All right, uniformly. And when that happens, we don't regard it as harmful to the structure. Okay, when the structure settles uniformly, we don't regard it as being harmful to the structure, because the weight of that structure will definitely cause that structure to undergo settlement, especially the influence of groundwater, because groundwater influences this settlement. In the clay soil, it causes it to swell when the clay soil absorbs. Once it absorbs and swell, there will be a decline, okay? Within that period, there will be a decline. It might not be noticeable, all right? In the case of sandy soil, there will be liquefaction, all right? So it's important that the kind of foundation that we give to our structure will determine will determine the stability of that foundation with respect to the effect of groundwater. All right. So now I want you to also understand. I want you to understand that foundation plays a very integral role, in the stability of our structure. So we must consider the effect of groundwater. In most cases, we can do drainage. And when you do drainage will help to would help to lower the piezometric level of our groundwater. And once the piezometric level of our groundwater is reduced, okay, you see that it will be distant from our foundation. So some cases there are permanent dewatering exercise that normally takes place, especially in areas that experiences high water level. All right, there are cases to do permanent dewatering. All right, thereby by doing so, it will reduce the water table in that location. All right, so we must understand this intricate nature of our foundation with respect to groundwater. All right, now groundwater also in some cases you see that during the excavation water tend to gush out. Water tend to settle in our foundation trench. This is as a result of the rise in water table. All right, once there is rise in water table and you do excavation without understanding the level of groundwater in that area, you see that you have challenges of waterlogging of foundation trenches. And most times when we face such, we do dewatering. Now it is important that in a clay soil, when you do your dewatering, you must introduce sharp sand. All right, you must introduce sharp sand, or you do a weak concrete, and apply on that surface, on the trenches, the surface of the trenches, the bottom surface of the trenches. You introduce either your sharp sand, okay, or a weak concrete, on it, and compact before introducing the main concrete. The reason is that at that point in time, you need to do some level of stabilization of that base before it can receive the main concrete. Otherwise, settlement will be inevitable. That is, in most cases, especially where you have where you intend to do a strip foundation. All right, where you intend to do a strip foundation, because most settlement takes place more on strip foundations. All right, now in that strip foundation, you see that it is the concrete base that have that interface with the soil. All right, so in the area where that concrete base covers, and when the soil swells, that concrete base tend to respond to that swelling nature of the clay soil. Okay, tend to displace that movement. Okay, that movement tend to a kind of is being displaced. The soil is being displaced as a result of that swelling tendency of our clay soil, and that brings about differential settlement, because all through the length of that trench, the soil makeups also differs. Okay, it also differs. So that is why you see when you do excavation, if you take note of the soil makeup and the texture, you see that even within a close range, you see the coloration of our soil showing difference. Okay, this is also attributed to certain characteristics of the soil. So that is why it's important we must carry out tests, soil tests, geotechnical investigation of that soil, so we can be able to be abreast with the soil makeup in that location, and also to enable us provide suitable foundation for that kind of soil with respect to groundwater. All right. So like I said, when you have a trench, you see that you must stabilize. Otherwise, when you do your base and you put up that structure, okay, during the dry season, when the groundwater drops, you see that the clay soil will contract, and that will bring about the cracks formation, under your foundation. Okay, and when those cracks are formed under your foundation, that is what brings about differential settlement, because the weaker part will tend to move faster than the other part. And when a particular section of the building tends to slide downward, okay, leaving the other behind, that brings about differential settlement. That is uneven settlement, substructurally. And usually when that happens, you won't see it because it is below ground level. But be it that it is what carries the superstructure, it must transcend to the superstructure. It must manifest on the superstructure. Okay, it will be visible as cracks. Okay, so that is why we must not neglect, we must not neglect carrying out or doing the needful at that foundation stage, because whatever we do there, will have a grave impact on the stability of our structure. Okay, because definitely once groundwater rises, especially in the case of clay soil, it will regulate the behavior of our clay soil. It's also applicable to sandy soil. It causes liquefaction. Okay, and that is why you see once there is vibration close by, it causes that structure to be displaced, although it is not noticeable. But constant, of this, seasonally, all right, will bring about the manifestation, in our superstructure, in the form of cracks. All right, so it's important we have this, in mind. All right, so apparently when we do a foundation and we encounter water, usually it causes a kind of muddy water. All right, if there is need to introduce sharp sand, all right, to be able to interact with those mud to give it a more stable soil, in order to receive the main concrete for our base. All right, because once you don't do the needful during these seasonal changes, it will have a direct impact on the stability of our foundation. All right, so please, if you're just joining us, you're welcome to the Engineer Construction Lecture Hub, and the topic of discourse today is the effect of groundwater, to foundation stability. Our paramount objective is to ensure that our foundation is stable, because once our foundation is stable, it means that the longevity of our structure is guaranteed. All right, it is guaranteed. So we must do everything possible to ensure that we give our foundation the needed stability that it requires by regulating the groundwater. Okay, we regulate the groundwater. All right, although in some cases the groundwater gets to the highest groundwater level, that is the piezometric level, is at let's say 5 meters, 3 meters, 2 meters below ground level. All right, so it's important we carry out studies, okay, before we embark on our construction, especially in the case where we intend to do a deep excavation. All right, when you want to do a deep excavation, you must understand the piezometric level of our groundwater. All right, so that it will enable us know the depth to go, so that at the end of the day, it will not have a direct impact on the stability of our structure. All right. So if you have any questions as regards to the topic of discourse, you can as well, drop it at the comment section. Answers will be provided. If there are contributions as well, you can also drop that at the comment section. All right. So back to what I was talking about in respect to groundwater. Now there is something we call dewatering. In the course of the lecture, I've talked about it. Now, dewatering is an exercise that involves removal of water. Okay, we tend to remove water when we are being faced with the water challenge during construction, because dewatering has to take place during construction. Okay, not before construction. Is during or what? Okay, before construction. That is before carrying out maybe concrete works and all of that. But before you start construction, excavation is part of during construction. So it is when you have excavated the soil that you will encounter water. All right, and that is when you have to do dewatering. All right, and dewatering has to do with the removal of water from the area where construction activities is designated to take place. All right. Now, after your construction, all right, there is need to do subsurface drainage. Depending on the kind of structure you have, you can do subsurface drainage. Now, that subsurface drainage will help to regulate the groundwater level. All right, even when there is rise, subsurface drainage will help to regulate groundwater with respect, for it not to have direct or have impact on our foundation, the stability of our foundation. So I want you to understand that most of these settlements that we have, okay, are associated to groundwater. The seasonal rise of groundwater influences our foundation. All right, because once this soil gets this water, they are, for example, the clay soil, which is cohesive, tend to swell. All right, tend to swell, and the load, displaces that swollen soil, that area, the contact area. Okay, there is a displacement, and when that displacement occurs, it results to differential, or rather settlement. Now, depending on the movement, it could be differential, it could be uniform settlement. All right, so like I said, once it is uniform settlement, it means that that settlement is safe. All right, it is safe, and the uniformity in terms of settlement also, has to do with the kind of foundation type that was adopted for that structure. If you go for a strip foundation, for instance, all right, definitely the kind of settlement you experience there will be differential. It will be differential. All right. Then in the case of maybe you have a strap footing, all right, where you have a strap footing where you have all the columns connected, with strap beams, ground beams, all right, you will see that the settlement will be regulated because of the presence of those grade beams. All right, the grade beams will tend to bridge those areas that will tend to bring about this uneven settlement. All right, the ground beam will tend to bridge those areas. Because like I said, within your trench, the soil makeup differs as well. All right, the soil makeup differs even within a particular location. So it is important when you're dealing with your clay soil, due to its dynamic nature, there is need to regulate that tendency. And for you to regulate that tendency, you must introduce your grade beams, that is your ground beams. All right, depending on the depth of the thickness of the ground beam you intend to give, but there should be presence of ground beams to be able to regulate this movement that takes place as a result of the seasonal changes, which is usually influenced by groundwater. Okay, it is the groundwater that influences this behavior of our foundation. All right, and this groundwater is being is kind of regulated by season. All right, during the wet season, you see that due to the rainfall, the amount of rainfall, the groundwater level tend to rise, the water table tend to rise. All right, so during the dry season, you see the water will recede, the groundwater will recede. Now this fluctuation that takes place have direct impact on our foundation. It has direct impact on the stability of our foundation, and that also in terms of the type of soil also plays out in this context. So I've talked about clay soil, you know, in the course of this lecture. I've also talked about sandy soil. All right, then in some cases you see that we have a kind of loamy soil. All right, loamy soil in this case has a combination of your sand, your silt, and your clay, okay, in their proportion. So that is why it is regarded as a more stable soil among these other type of soils, okay, because all of these other soils are present in loamy soil. So when you have such a soil, you see that they will have to checkmate one another. Okay, what I mean checkmate one another, in a combination of your sand and your clay. When you have them together, okay, you see that the clay now have the tendency of swelling and shrinking. The sand now have the tendency of eroding once there is water. Once there is presence of water, it erodes due to its cohesionless nature. All right, so by the time you bring these two soil together, all right, you see that they will tend to checkmate each other. The sand will tend to checkmate the tendency of our clay soil. All right, when you have sand in your clay, okay, it will kind of regulate that amount of swelling and shrinking. Okay, then when you have clay in soil, in sandy soil, the cohesive nature of the clay will tend to bring those cohesionless grains of our sandy soil together. Okay, it will help to bring them together. So you see that when you have these two soils together, they tend to checkmate one another. By checkmating one another, will make that soil stable. It will bring about the stability of that soil. So in loamy soil, you see that the proportion of these various soil types are present in loamy soil. That is why it's regarded as the best soil, okay, even in agriculture. All right, so these are, you know, these are soils, different soils. All right, but all of these soils are, you know, to an extent are being influenced by groundwater. All right, and when the foundation, the structure, you know, the foundation rests on this soil, it is the foundation now that you know, behaves or responds to the behavioral pattern of this soil with respect to groundwater. All right, so we must have it in mind that when we want to carry out construction, we must understand the groundwater in that location. Then we can also come about and also know the type of soil that are, domiciled or situated in that location. That this will not help us to develop or make the right or a suitable foundation that can be able to, be stable, irrespective of the groundwater, the rise of groundwater, irrespective of its influence in the soil within that location. All right, the structure will still be stable. So the kind of foundation we adopt for our structure is also very important, okay? Because when you choose the right foundation, irrespective of the groundwater, it will not have that impact on the stability of that foundation. All right, so in some location, in some in some areas, okay, you see that we have more structures having cracks, more structures having cracks. All right, now when you do a study of the causes of those cracks, it's traceable to the foundation. All right, it's traceable to the foundation. And in some cases, you see that those structures are resting on a strip base, okay? And in a strip base, is not reinforced. It's mainly a thickness, let's say 150 mm thickness of concrete base. All right, when you have such base and you see this soil being influenced by groundwater, you see that that base will not be able to sustain the load that comes from the superstructure, because as this circle keeps on, so as the soil keep on, sorry for the break in transmission. There is a power outage, so I had to switch over. All right, so back to what I was talking about. So it's important that we look at, we understand the groundwater, then we I choose suitable foundation that can be able to withstand those behavior, when the soil is being influenced by the groundwater, okay? Because the type of foundation you adopt is very important. That is why in some cases when you have an extensive project, okay, that a very large magnitude of structures, and on a clay soil, it's important you adopt a pile foundation, because pile foundation will help to transfer that load to a more stable strata below. Okay, it will transfer that magnitude of load across several stratas to a more stable strata. All right, so it's important that we understand, and at that point you see groundwater will not have much effect on such a configuration. All right, so it's important we look at the choice of foundation with respect to groundwater, because once you choose wrongly in terms of foundation type for your structure, definitely groundwater will influence the soil that carries this structure, and most cases it results to settlement, and differential settlement are usually experienced, and that brings about crack formation all over our structures. All right, so we must do the needful when it comes to when it comes to the aspect of having a stable and a functional structure at the end of it, because the longevity of your structure is dependent on the solidity, okay, and the stability of your foundation. All right, so please do well to stick to Bengineer Construction Lecture Hub. More updates will be coming. I intend to come up on live sections to exhaustively discuss, some of these challenges, all right, we have in construction. Please, I also want to use the opportunity to, to inform us that most of the videos that I drop, all right, due to the lengthy nature, all right, due to the length of those videos, I will not be able to, drop them fully on my my timeline, my profile, all right. It will not be in terms of uploading, will not be fully uploaded. So that is why you see it splitted. So I'm really sorry for that. All right. So that is why I intend to be coming up on live sessions to exhaustively discuss some of these topics. Okay. So as we go on progressively, I'm going to be coming up live to, discuss extensively on some of these issues. So just bear with me on that. All right. There are some of my videos that are on Reels, and Reels are short videos. Okay. So those short videos, you can go to the playlist and see the various segments of that video, and as well you can find the full video on my timeline. So you look at the ones that the titles that doesn't bear parts. Okay, you trace those videos to the very one that doesn't have parts. That is the main full video for that particular those clips. Okay, so I decided to bring this because some persons have, sent me a direct message, talking about short videos and all of that, not having full clip of the lecture. So that is why I decided to bring this, so that we have that awareness. All right. So as we go on, I'm going to, be dropping live. I'll be coming up on live sessions to exhaustively discuss some of these points. Okay, so that we'll get, aware of all of these, basically to enhance a better construction approach. To enhance stability of our structure. All right. So please, if you have questions, contributions, you can drop them at the comment section. So I'm going to stop here for today. I will see you guys in our next live session. I want to use this opportunity also to appreciate every one of you. Thank you so much for your time, for sticking to Bengineer Construction Lecture Hub. I love you all. Thank you so much, and God bless you all. And bye. Thank you. Bye.